Hello and welcome to this final module in our course on understanding precisely how scan, fold and reduce work in Scala. More broadly, this module is devoted to the study of higher order methods on collections in Scala. These higher order methods effectively replace for loops and are the glue or the cement that bind together functions and collections in Scala. In this module, we will first study simpler higher order methods which operate on one element at a time. After that, we will move on to the more complex higher order methods which operate on multiple elements, specifically the scan, fold, and reduce families of higher order methods. Let's first understand why higher order methods are worth studying in the first place. Remember that higher order methods of collections take in function objects and then go ahead and apply those function objects to the contents of our collection. This makes them substitutes for loops. After all, for loops basically iterate over collections. For loops tend to break functional composition. In fact, it would not be an exaggeration to say that an absence of for loops from code is a good indication of whether that code is functional or not. And clearly, for any meaningful code to be free of for loops, higher order methods in the collection classes are extremely important. We can broadly classify higher order methods into two categories. Category 1 includes methods such as map, for each, and filter. These act on one element at a time. In contrast, other higher order methods such as scan, fold, and reduce operate on multiple elements, albeit via a running result. This means that functions such as scan, fold, and reduce are actually extremely powerful. We'll get to those in a lot more detail in a few minutes, but for now, let's focus on the for each style higher order methods. Let's plunge right away into a simple demo illustrating a whole range of simple higher order functions. As always, let's open up a Scala interactive shell, that's the REPL environment. There, let's define a simple list. It's a list of strings with the first three letters of each of the names of the weekdays. Let's start with the simplest higher order method for each. Here we invoke the for each method and we pass in a simple function, in fact a simple procedure object. That procedure object just prints out the value of each element of the list to screen. The for each higher order method has no return value. So for that reason, any function object that you specify only makes sense if it's a procedure. If the function object that you specify has a return value, well, that return value is going to be ignored. In this instance, our procedure has a side effect. It prints out the value of the corresponding element to screen. Notice the use of the placeholder character underscore. This is a shortcut. This is a way of telling Scala for each element in the list, bind in the value of that element in place of the underscore. And that's exactly what happens. Each of the list elements is printed out to screen as you can see above. The for each higher order method is perhaps the least functional member of its family because it does not return anything, it cannot be composed or chained. In contrast, the map method is very similar to for each, except that it creates a list, an output collection with the return values of each iteration, with each application of the function object. Here we invoke the map method passing in a very simple function expression where we check whether the value of the corresponding element is equal to Monday. The result of this is a list of booleans. You can see that only the first element is set to true because only the first element on our list is actually equal to Monday. This list could then be used to invoke other higher order methods and we could chain the function calls one after another. The example above shows the use of a function expression. Let's explicitly create a function object and then go ahead and pass that function object into map. We've created an object of type function1 because it takes in one parameter, that's a string, and returns true or false depending on whether that string is or is not equal to Monday. We go ahead and invoke the map method passing in this function object which is called isManicMonday, and the return value once again is a list of booleans. As before, only the first element is true. That's because only the first element is equal to Monday. Let's move on to another simple higher order method called filter. Filter takes in a boolean predicate. It takes in a function whose return value is always either true or false. The return value from filter is a list. that list contains only those elements of our original object which evaluated to true. Here you can see that we call the filter method with our function isManicMonday, and consequently the return value includes only the element Monday. None of the other values in our original list made it into the output. Closely related to the filter method is the partition method. Partition, just like filter, will take in a function object which returns a boolean, either true or false. Partition will return two lists. The first list will contain all of the elements in the original collection which evaluated to true, and the second list in which all of the elements evaluated to false. In our example here, we invoke the partition method using the function object. The Boolean function object isManicMonday, and the return value is a tuple of two lists of strings. The first list includes only the value Monday because only Monday returned true when invoked with the function isManicMonday. The second list in the tuple includes all of the other values in our original collection called weekdays. Higher order methods can also be used to create a new collection in which the elements are sorted according to some criterion. This is the sort by higher order method. You can see here that we are sorting by the first character of each element. Notice how each string is represented as a collection of characters. And so when we choose to sort by the 0th character, we get back a resulting collection sorted by the first character of each word. Notice also how, because our original collection is an immutable one, we get back a new collection. The original collection is unchanged.